Well, hi there. So in this video, we're going to do a deep dive into the branch of math called game theory. We're going to use game theory in economics to model how oligopolists, or whenever we have very few decision makers, how they make strategic behavioral decisions. In other words, because they are interdependent, because one person's outcome is dependent on what another person decides to do, we're going to look and see what should they do given that information. So let's get started. So the first section here of game theory talks about just what it is. Game theory is a study of behaviors in interdependent situations. It is math, and it gets a lot more complicated than kind of what we're going to be dealing with here in our just lecture today about oligopoly. But remember that oligopolists engage in this strategic behavior because their outcomes depend on what the other person does. This is called game theory. We can kind of model their behaviors. Some terms to know. This big table, right, that starts with kind of the two players, if you will, and we call the players the agents or the firms or the companies, right? It's the two decision makers. This shows what we call a payoff matrix. And this payoff matrix tells us if this person and this person decide to do these given things, they will get these payoffs, the numbers that are actually in the box. And so the numbers that are in the box correspond to when this person and this person makes these given choices. So just to read this payoff matrix really quickly here, we have two people, we have two gangsters. And so this is a classic example of a payoff matrix called a prisoner's dilemma, because the setup here would be that we have captured both of these two gangsters, El Chapo and Al Capone. And we've got them on little minor charges, right? We've got enough to put them both away if they both keep their mouths shut about their terrible crimes. If they both deny that they're involved with anything, we've got enough to put them away each for 3 years. And the left number, the 3 years here, goes with Al Capone. And the right number, the 3 years here, goes with El Chapo. So to read the first box, if they both confess to all of their crimes, this first number, 20 years, means that we're going to put Al Capone away for 20 years. And the second number, 20 years, means El Chapo gets 20 years. Now, where it gets interesting is we've got them in two separate rooms, and they're going to make their decisions immediately, whether they want to confess to the full range of their crimes or keep their mouths shut. And if what we're going to offer them is, we're going to say, if you confess, then we're going to let you off really easy and put you in prison for only 1 year because you've done some bad things, but 1 year and you've confessed. And the other guy, if he denies, he's going to get 30 years. So the deal we'll offer them is if one of you confesses and the other one keeps his mouth shut, you, the one who confessed, you get a year. The other guy goes away for 30. If you both confess, though, we've got enough on both of you. You're both going away for 20 years. And if you both keep your mouths shut, you're both getting 3 years because we've got enough to lock you up for a little bit of time. So what we can do is solve this payoff matrix. And what we'll find with the prisoner's dilemma is actually if they do what's in their own selfish interest, they're actually going to get the worst combined outcome, which is the most years in prison, if they play selfishly. And that's typically what we expect kind of companies to do, is not cooperate. So we would say they do not cooperate. So sometimes this is called the non-cooperative outcome. It means that they're competing with each other, right? So let's see. First, we would play as one player. So we're going to identify and be like, okay, I'm going to play as Al Capone. And if I'm Al Capone and I think El Chapo is going to confess, that's going to put us into this column. If El Chapo confesses, we're either going to get 20 years by confessing as Al Capone, right? So that's our first choice. Or we can keep our mouths shut and get 30 years. And this 30 years is the alternate to us confessing and getting 20 years because we're Al Capone. And you might be looking at this and say, but what about my 3 years? Well, the 3 years only happens when El Chapo denies. And in this first little scenario, we're going to make an assumption if we're Al Capone. What if El Chapo sings? What if he talks, right? He confesses. And well, would we prefer 20 or 30 years? Well, we would prefer 20 years. So I'm going to circle 20 years because I know as Al Capone, 20 is better than 30. Now, if I think I'm Al Capone and I think El Chapo is going to deny, I'm Al Capone and I think El Chapo is going to deny, I could get 1 year by confessing, right? That's my first choice here. Confess, I get a year. If I deny, I'm going to get 3 years. I keep my mouth shut and El Chapo keeps his mouth shut, I'm going to get 3 years. So I'm going to confess in that scenario if El Chapo denies. So I'm going to circle 1 year. Now, because I am Al Capone and my outcomes here are to always confess, right? It means that if El Chapo confesses, I'm going to confess. If El Chapo denies, I'm going to confess. I'm never rationally going to deny what I've done here. I have what we call a dominant strategy, right? A strategy is a choice. That's what confess and deny is. And because I'm always doing this strategy, I'm never choosing the other one. I would say that confess is my dominant strategy. Now let's look at it from El Chapo's perspective. Well, El Chapo knows that Al Capone is going to confess. He knows that that's the dominant strategy. And so El Chapo can confess and get 20 years. So I'm going to kind of switch thinking. Like before, I was comparing these 20 and 30, right? I could get this one or I could get this one. I could get this one or I could get this one. But now, as El Chapo, I'm facing 20 or 30 years here. So I'm kind of comparing these two numbers, right? I'm comparing these two numbers because I could confess and get 20 years if Al Capone confesses, which I know he's going to do, or I'm El Chapo, I can deny and get 30 years if if Al Capone confesses. So 30 years or 20, I'm El Chapo, I would rather get 20 years. Now, El Chapo knows that Al Capone is going to confess, but he could run the numbers even if Al Capone plays irrationally and denies. If Al Capone denies, El Chapo can confess and get 1 year or can get 3 years by denying. And so 1 year beats out 3 years, of course. And so El Chapo will also confess in that circumstance. So El Chapo always is confessing. And so I would say that El Chapo also has a dominant strategy to confess. They both do. And as a result, we can see that this prisoner's dilemma yields 40 years in prison, the worst possible outcome for them. If they were able to cooperate, if they had kind of been able to collude, then they would have chosen deny. 6 is obviously less than 40, but they can't. This is them competing with each other, and it's a one-shot deal, right? You confess or you don't. So we have now, as a result of two circles in a box, we have what we call a Nash or a non-cooperative equilibrium. And the non-cooperative equilibrium is maybe easier to understand. It's the place where we'd end up if we don't cooperate. Now, the Nash equilibrium is just the same name for it, right? So sometimes you'll see it called a Nash or a non-cooperative. It's just the same name. The guy who came up with his name, John Nash. And this outcome has a little bit more of a technical definition than just like the outcome where they end up if they don't cooperate. It is that, but it's actually an outcome where neither one of the two people, the two players, right, neither Al Capone or El Chapo, neither one will change what they're deciding to do unless the other one simultaneously changes. In other words, no participant can gain by changing as long as the others stay the same. So in other words, there's no reason for El Chapo to switch. You're going to look at it and go, but El Chapo's getting 20 years. And it's like, well, yeah, but if El Chapo switches and gets to deny, El Chapo's going to get 30 years. He's not going to gain by just switching from confess to deny, so long as Al Capone still confesses. Now, they could break out of this non-cooperative agreement if they both simultaneously went, okay, on three, we're both going to deny. 1, 2, 3, boom. And then they both switch over to deny, and then you end up in this 3-3 box. But the only way they can do that is by working together, by cooperating or colluding, and they can't do that. So as long as you have this outcome where no participant can gain, as long as the other people remain the same, we call that a Nash equilibrium. You can identify it because there will be two circles in a box. Now, with two-player games like what we've got here and two strategies like what we've got here, there can either be 0, 1, 2, or 4 Nash equilibria. 4 would be actually they're all stable outcomes. 2, they're going to be in diagonals typically. Typically, they'll be diagonals, but not always. And 1 is the case that we have here. We have 1 Nash here. You could also have an unstable game with no Nash equilibria. So let's try it out with a different example. Lowe's and Home Depot, should they focus on contractors or homeowners? And these are billions of profit. So in this one, bigger numbers are better, right? First thing to identify with these is it bigger, better, or smaller? Prison years is obviously smaller is better, but with profit, we want more. So let's play as Lowe's for a second here. We assume Home Depot is going to focus on contractors. We don't know right now, but we'll see. And we could focus on contractors and get 25, or Lowe's could focus on homeowners and get 30. Well, they're going to focus on the homeowners and get 30. So we're going to circle that 30. Now, if I'm Lowe's and I think Home Depot is going to focus on the homeowners, I could get 30 by going for the contractors, or I could get 20 by focusing on the homeowners. So I'm going to go for the contractors in that case. 30 is bigger than 20. Now, here you can see that Lowe's is not always doing the same thing. Lowe's is not always picking homeowners. Lowe's is not always picking contractors. So Lowe's does not have a dominant strategy. Let's play as Home Depot. Now, Home Depot, if Lowe's decides to go for the contractors, Home Depot can get 35 by going for the contractors or 30 by going for the homeowners. So I'm comparing it across now because I'm Home Depot, contractors versus homeowners. 35 is bigger than 30. And then what if Lowe's focuses on the homeowners? Well, I could go for the contractors and get 50, or I could go for the homeowners that Lowe's is going for and get 25. Well, 50 is beating out 25. So for me as Home Depot, I'm actually always going to go for the contractors, right? I have a dominant strategy. 35 is bigger than 30, 50 is bigger than 25, but Lowe's does not have a dominant strategy. So first it says, where will they end up if they do not cooperate? We would say Lowe's, homeowners, and I'm just kind of describing the strategies they're choosing. I'm saying Lowe's homeowners, Home Depot contractors, Home Depot contractors. And if I had more than one, I would just label them both, right? So I'd say like, here is that Nash equilibrium. Does either player have a dominant strategy? Yes. Home Depot always picks, what did we say they pick? They always pick contractors. They always pick the contractors. And so we say that Lowe's does not, because sometimes they switch. But yes, Home Depot is always going for the contractors. By the way, that actually is the strategy of those two companies. Right now in the market, Home Depot kind of focuses on the contractor market actually for home projects, and Lowe's focuses on the homeowners projects. It's an interesting thing if you get into the weeds of their profits. Now, game theory can reveal strategic behavior in a couple of ways. We've kind of talked about these. Non-cooperative behavior means they're ignoring their effects on others. They're just picking their own selfish outcome. That's typical in something like a prisoner's dilemma. But most oligopolists don't operate that way. They know that like they're going to be competing against these people over and over and over again. And so that's actually why you would often see them start to engage in tacit collusion. And excuse me, the most common form when they actually begin to tacitly collude excuse me, is they'll actually start to engage in this thing called a tit for tat strategy. And that all it means is that both of the two players will look at what's the best thing for us combined, right? Both of them will look at what's the best for us combined. And then, so they're starting off cooperative. And then they will continue to do that until the other player cheats, right? And like kind of switches to something else. In which case, then the first player will repeat and play what that other player just did. So in other words, they're basically going to play nice until one of them doesn't play nice, and then the other one will say, I'm going to do what you just did, right? So if, for example, they're both kind of pricing high for a really long time, and then one of them cheats and prices low, well, then the next quarter, the next 3 months of the year, the other company will say, well, yeah, take that. We're going to price low as well, even if it actually hurts them. Because what they'll do is they'll kind of price low to punish the other company. And then the other company is like, ow, that hurt. We got less profit. Let's raise our prices. And when they raise prices, then the other company will go, okay, now you're going to play nice again. We'll raise prices too. And we'll go back to that kind of that level where we're making the most money. So they'll start to see this tacit collusion emerge out of iterated or repeated interactions. And it's often through this thing called a tit for tat strategy. It means playing what the other guy did in the previous round. So hopefully this helped you understanding game theory a little bit, understanding how it's used in terms of oligopoly. I'll see you next time.